Hello everyone. Today I am excited to introduce an enormous dataset HaGRID to build and hand gesture recognition system concentrating on interaction with devices to manage them. That is why all 18 chosen gestures can be interpreted as a specific action. The HaGRID contains 550,000 images and bounding box annotations with gesture labels to solve hand detection and gesture classification tasks. The low variability in context and subjects of other datasets was the reason for creating the dataset without such limitations. Using gestures in human communication plays a vital role. They can emotionally reinforce statements or entirely replace them. Moreover, hand gesture recognition can be a part of human-computer interaction to determine the gesture a person shows to the camera and perform an action corresponding to it. Since people universally use gestures in real life, building HDR systems can improve user experience and accelerate processes in such domains as the automotive sector, home automation systems, multimedia applications, and a wide variety of video streaming platforms. The HDR system should be designed with gestures suitable for controlling it. There are at least 50 hand gesture recognition datasets. The gesture baskets can be divided into three main groups of style: sign language, semaphores, and manipulation gestures. The last two groups find applications in home automation systems and human-computer interaction and perform semiotic and ergotic roles accordingly. As we aim to build an HDR system with a mostly semiotic role by adding manipulative gestures solely using heuristics, only dataset with static gestures were reviewed. Since the HDR system users will show gestures at a distance from the device, the trained model needs to capture the whole context and search for a person's hand in it. However, some datasets with static gesture are intended for person-independent systems and contain samples of no human body with only hand parts, cropped hand images, which is why they are unsuitable for us. To our knowledge, there are only 4 datasets for static gesture recognition with context and appropriate annotations, including hands, shapes, out hands, and lariat. They are not appropriate for constructing our HDR system due to the lack of heterogeneity in such characteristics as sense and subjects, which negatively affects the heterogeneity in lighting conditions and subject to camera distances. In the ablation study, the experiments proving the need of such characteristics for neural network generalization are provided. The above limitations push us to create a new HDR dataset with no such weaknesses. The dataset was created in 4 stages: the image collation stage called mining, the validation stage where mining rules and some conditions are checked, the filtration of images, and the annotation stage for markup bounding boxes. The classification stage is built into the mining, validation, and annotation pipelines by splitting pools for each gesture class. Note that all crowd workers are aware the transfer of personal data to third parties and the presence of dubious content are prohibited. HaGRID includes more than 550,000 images divided into 18 most intuitive classes of gestures. The HaGRID was recorded by 37,000 unique faces in at least as many unique scents. The subjects' ages range from 18 to 65 years old and are gender balanced. We considered the scent specifics of such applications as home automation and video conferencing services, and we preferred mainly indoor context with considerable validation in lighting, including artificial and natural light. Besides, the dataset includes images taken in extreme conditions such as facing and standing with one's back to a window. The HaGRID was annotated by bounding boxes. Such a choice allows us to train lightweight hand gesture detectors or recognize swipes and other dynamic gestures for interaction with objects on the device screen. Due to the large dataset size, each model was trained from scratch on full-frame images. The metrics were calculated on the testing set containing 90,000 images. High performance demonstrated the dataset's ability to train models without added complexities in the training stage. The observance of specific rules is applied to build a dynamic gesture recognizer using the dataset with only static gestures. The essence of this approach is to divide the dynamic gesture into two components, the initial and final gestures. We developed the gesture prediction queues to implement dynamic gestures as an empty list of a certain depth filled with events on each frame. Queues verify the correctness of the execution of a dynamic gesture. An ablation study was conducted to assess the main heterogeneity characteristics impact individually. We tested the need for the large amounts of data, diversity in brightness, subject to camera distances, and number of subjects by changing these characteristics and freezing the rest. The quantitative needs results for classifiers and detectors demonstrated an upward trend as the training set increases. The classifiers and detectors' performance depends on subject to camera distance diversity both for the HaGRID test. Looking ahead, we plan to expand HaGRID, adding more gestures and scenarios. Our goal is to continually improve its relevance and applicability in emerging technologies and interfaces, further bridging the gap between humans and computers.